For today's video, or this current video, I'm looking at page 35 in the textbook. And let me get to page 35. This is, I believe, yes, lesson 12. And this is still about scientific passages. I believe we're still talking about how we perceive color or something to do with color. So let me just review. We talked about the fact that chromatic refers to color. Bias is leaning toward one side more than the other. We talked about wavelength is the length of a single wave, and we looked at the rainbow. Do you remember which color has the longest wavelength? It's red. And which color has the shortest wavelength? Is violet. And while I'm thinking about it, let me give you this. I meant to do it the other day. This will help you remember the colors of the rainbow. If you can remember the little acronym, I always thought of it as a name, Roy G. Biv, where R is red, that's the longest, orange, yellow, green, blue. Indigo is sort of a cross between purple and blue. And then violet is what I would call purple. So those are the colors of the rainbow. Red has the longest wavelength. Violet has the shortest wavelength. We learned that retina is the back of our eyeball on the inside. Neural means nerve. Visual relates to the eye, and cortex is part of the brain. So we learned a lot in that little paragraph. Okay, let's carry on here. It says to read the passage and answer questions 1 through 4. Again, I'm on page 35. It turns out that the photo of the infamous blue and black or gold and white dress was overexposed. This meant that our brains had to make certain assumptions. Was the light source in the photo? Was it taken in the shadows? Was it taken in the sunlight? Was it taken in artificial light? Our brains would read the lighting in each situation differently. Our brains would take away the color of the lighting to find the true colors of the dress. Our brains do this automatically without our realizing it. As humans, we have adapted to see in the daylight. But think about the different times of day. The light and color change. The chromatic axis of the day can go from the pink of sunrise to the blue-white of noon to the red of sunset. All day long, our brains are trying to figure out the bias of the daylight chromatic axis. The people who thought the dress was photographed in shadow saw white and gold. Their brains subtracted blue because shadows are blue. The people who thought the dress was photographed in artificial light thought it was blue and black. Their brains subtracted yellow because artificial light is yellowish. That does not entirely explain why people saw the dress differently. Among people who thought the photo was taken in shadow, 4 out of 5 said the dress was white and gold. Among the people who thought it was taken in artificial light, about half thought the dress was white and gold too. One scientist believed that the difference was due to how long each person was in the daylight. His experiment showed that people who wake up early saw the dress as white and gold. People who slept late more often and were exposed to more artificial light identified the dress as blue and black. What color was the real dress? It was actually blue with black lace. Okay, let's take a look at, first of all, the terms that may be considered scientific, academic. There are quite a few here. And you may mark terms that I'm not marking, and that's okay. If there are words that you don't understand, go ahead and mark those. I'm going to pull infamous, overexposed, artificial. That one you may not mark, but I'm going to mark that one. There's that word chromatic again, but this time it's with the word axis. There it is again, chromatic axis. There's artificial again. Artificial is one that shows up a lot in this passage. There it is again. And there it is again. I'm sure I'm missing some of them, but I'm going to go ahead and highlight assumptions as well. Okay, I think that's all I wanted to get. There may be some that I've missed, but we'll come across them as we need to. So first thing I'm going to do is identify the meanings of these words. Okay, infamous. This one you might have to consult the dictionary. I'm going to just give you a definition so we don't have to do that. Infamous is famous in a bad way or in a negative way. Adolf Hitler was infamous. He was famous, but not in a good way. Overexposed means exposed or in the presence of, you could say, to too much light in this case. If you become overexposed to too much sunlight, you will get a sunburn. So overexposed is too much of light in this case. An assumption I'm just going to call that an educated guess. To the best of my knowledge, it's true. So it says that your brain has to make an educated guess about when a photograph was taken or how much light was exposed to that dress when the photo was taken. Then we have artificial. This is probably one that you've heard. Artificial is fake. You can have artificial snow at ski resorts, artificial sweeteners to replace sugar. Artificial light is not sunlight. It's light produced by electricity. Chromatic, we know this one because chroma is color. Anytime I see something with chroma, I think color. And axis is a fancy word for a line, a straight line. So they're talking about the chromatic axis. They're talking about the line of color that proceeds through the day. The day starts with pink at sunrise, and then at noon it's blue, white. It's very bright at noon. And then at sunset we see red. So as the day progresses, we get different colors of light. Okay, let's outline our passage. I think I'm just going to use that same format as I did before. You can make this as detailed as you want to. That is way too big. Try again. So I'm going to make this space for my topic and then one for my main idea. And then let's look at some details. I'm going to come up here to this first paragraph where we're talking about the blue, black, gold, white dress. Our brain has to make assumptions. What was the light source of the photo? Was it in the shadow, sunlight, or artificial light? So this is telling me, I'm going to make an assumption right here, that the light source affects, this is a verb, so I want the affects with an A, the appearance of a photo. A dress photographed in the shadows will not look like a dress photographed in the sunlight. So the light source will affect your photo. Our brains would read the lighting differently. Our brains would take away the color of the lighting to find the true colors of the dress. Our brains do this automatically without our knowledge. As humans, we have adapted to see in daylight, but daylight can be different times of day. It can be early morning or noon or sunset, and our brains are able to distinguish different times of daylight. So our brains can distinguish different degrees of sunlight Sunlight is natural light through the day without us realizing it. Your brain just does this. You don't have to think about it. Okay. Then the third paragraph says that this does not entirely explain why people saw the dress differently. Even though these things are true, there were other factors. There appeared to be other factors about the dress. It wasn't just about the things we've already talked about. And then our last paragraph, one scientist believed that it depended on how long you were in daylight. So you could say that one scientist said that the dress perception was affected by the viewer, meaning the person looking at the dress, So this would lead me to think if you showed this picture to someone outside in the sun, they would see it one way. If you showed this to someone who might be working the night shift at the hospital in the basement, that person might see it a different way because they've not been exposed to sunlight. So, what is the main idea of all this? Well, light source affects the appearance of a photo. Our brains can distinguish different degrees of sunlight through the day without us realizing it. There are other factors with the dress. One scientist said that we're affected by the viewer's time in the daylight. I'm going to say this on my main idea. A person's perception of color can depend on several factors. This is not just explained by one particular factor. This is something that there are lots of variables involved in how we perceive color. So, a topic for this particular story, I'm going to use a question on this one. Why do we see the colors we see? Now, you could make it specific to the dress. I think that would not be a bad idea since it's talking about the particular example of the blue and black dress. Okay, let's try some questions. Number 1, what effect, remember when it's effect, it's a thing. When it's affect, it's a verb. Sorry, not a think, a thing. What effect did the overexposure of the photo have? The photo was taken at night, so it was difficult to see the colors. The light was so powerful that it bleached out the colors. People with a lot of exposure to the sun easily identified the colors. People's brains had to decide which type and color of light to take away. So I think I know the answer, but before we decide, let's look back. Let's find that word overexposure, and it is right here. So what about overexposure? This meant that our brains had to make certain assumptions. Was it taken in the shadows, in the sunlight, artificial light? Our brains would take away the color of the lighting to find the true colors of the dress. So I like option D on this one. People's brains had to decide which colors to take away. Number 2, what is the chromatic axis of the day? Well, chromatic means color. Axis means line. So what is the color line of the day? It is how the color of light changes during the daytime. It is the color of the sunlight at sunrise and sunset. It is the amount of artificial light a person is exposed to. It is how a person's brain knows that shadows are blue. Well, let's look back at chromatic axis and see what it says. Okay, here we go. I've already highlighted it. The chromatic axis of the day can go from the pink of sunrise to the blue of noon to the red of sunset. All day long, our brains are trying to figure out the bias of daylight chromatic axis. So this happens all day long, and it relates to natural light. I can eliminate B, as in boy. It is the color of sunlight at sunrise and sunset. No, it's all day long, including noon, afternoon. So this one is not my answer. It is the amount of artificial light. No, it's the amount of sunlight a person is exposed to, or it's related to sunlight. It's how a person's brain knows that shadows are blue. That may or may not be true, but we're talking about daylight, not shadows in particular. So I'm going to go with A. It is how the color of light changes during the daytime. Alrighty, number 3. What can you conclude about why the late sleepers were more likely to identify the real colors of the dress? Okay, let me think. Late sleepers, these are people who don't get up at sunrise. Spending more time in artificial light makes it easier for someone's brain to identify the true colors of objects. They spent more time in artificial light, so their brains assumed the photo was taken in artificial light. The brains of people who rise early are more tired than the brains of late sleepers. The brains of late sleepers subtract the color yellow from every object they see. Well, I have an idea that it's B, as in boy, but let me look back just to be sure I'm not missing something. We are talking about the late sleepers. And it tells us a little bit about the late sleepers. It says that people who slept late more often and were exposed to more artificial light identified the dress correctly. So there seems to be a connection in sleeping late, which means that you're exposed to more artificial light. Think of the person who works night shift and they sleep during the day. So the only light they're exposed to sometimes is late in the afternoon or at night when we have artificial light. I'm going to go with B, because artificial light, their brains assumed the photo was taken in artificial light. So these people are used to artificial lighting. They don't get as much sunlight as someone who rises early. Okay, what color was the dress? So this one is stated for me in the last sentence, very last sentence. It was actually really blue with black lace. So of all these questions, to me, that is the easiest one, because I can just look back and see the answer. Blue with black lace. Okay, I'm going to stop this video and we will pick up in the next video on page 36.